Here we have a question, June 2011 42 variant, question number 5. And what a question is: two particles P and Q are thrown vertically upward from the horizontal ground at the same instant. It means I say stopwatch on and I throw the both particles are thrown upwards. So it means same instant. It means, and speed of projection P and Q is one is 12, one is 7. So P speed, initial speed is 12 and Q initial speed is 7. And the height attained by the both particles above the ground is this one. It means ultimately they will stop on the top. So let's see now. So he said that after second, the height of the particle representing by HP and HQ. So each particle comes to rest at returning to ground. So find set of values for which the particles are traveling in opposite direction. So let's start. This is a very interesting part. First of all of you know, I just tell you what is technique to get opposite direction. Look, starting, they are traveling in same direction. Okay, both are traveling in same direction. Okay, so let's see now. So how we can do it? How we can do it?
Sir, sir, you're muted.
So for Q, what is the situation we have? So for Q, so same story. Starting speed 7, ending speed 0. Gravity going upward -10. Time is question mark. So let's see how much time will take to reach on the top. So start ending speed 0, starting speed 7, gravity is -10, and t. So I get time, how much? I get time is a 0.7 seconds. So now it is a very clear approach. I give you idea that let's say that they are starting same time. So when time, because this, it will turn back early. How I know? Because particle P, particle P will turn after 1.2 seconds. And particle Q will turn after 0.2 seconds. So this is a less time. So it means that when I just show you some idea, when for example, you can see from here, when P was traveling, okay, it is going upward, and Q was traveling, and here. So when it time is a 0.7 seconds, okay, it will start to turn downwards. I hope so. Got a point. This is a P and this Q. So this is a time. This is a time because he was asking what set of values, not one time, different set of values of t when the particles are moving opposite directions. So it means starting point, look at before 0.7 till 0.7 till 0.7 seconds, they both are traveling upwards. Both are traveling upwards. So they have same direction. But as this particle reach on the top, the time becomes 0.7, then Q will turn back. When Q will turn back, but P is still moving upwards. So that is a time he's asking that Havan is opposite motion. And what I believe that naturally it will take 0.77 upward, 0.7 upward, and 0.7 downwards. So total time it will take is what? 1.4. But P will take how much to reach up? 1.2. And 1.2 it will take time to reach on the top. So it means the answer is what? Starting from 0.7 and ending 1.2. This is my answer. You ask him how you know, sir, 1.2 here. No, logic very clear. Because P will stop what time? 1.2 seconds. When it stop on the top and it will come downwards, look at here. 0.7, it will turn back. I give an idea. 0.7, it turns back. And it will turn back after 1.2. So it turning at 0.7, it turning at 1.2. So when it turning up 0.7 second, that time they will move opposite direction. How come? It is going upward, is going downward. So they have opposite direction. And as it will stop and turn back, then condition false. Why false? Then both are moving downward. So that is our ending time. I hope so the point is very clear, and we have to stop our stopwatch there. That after that, so I hope so the point is very clear that starting time when they follow the condition. And what is the condition? They must move in opposite direction, and that is only possible in starting. They are moving upward, and they start moving opposite direction when time reaches at 0.7, and after this reach on the top, the particle move again same direction. Both are traveling downwards. So stopwatch off. Here stopwatch on. Here stopwatch off. And I hope so the point is very, very clear. Let's talk about part number 2. Part number 2 is saying at a certain instant P and Q above the ground have these conditions fulfilled. Find the velocity P and Q at this instant. This is easy question, not that much harder. So let's try to use it. Both are heights concerned. We have 3 formulas. You know it very well. One formula, V is equal to U plus AT or GT. Second is S is equal to UT plus half GT square. Third is a 2AS is equals to V square minus U square, or 2GS. Okay. So this formula is not valid in this part number 2 because it has no distance. We can apply this also. We can apply this as well. Okay. Both formulas are valid, but I think so I will go for it. Okay. S. So let's start. So I will find for both particles P and Q. Okay. Data is very clear mentioned here. This one mentioned here. Okay. And S is equal to U. S is equal to UT plus half GT square. Okay, height of this is a P particle, height of P. U is what for the P particle? You know it very well. This is a 12. So 12T plus half times 2 and negative 10 times 2, 12 square. Okay, no, it's not 12, sorry, T only. T square. Okay, because time I don't know. And I got 12T and this is cancelled. I got minus 5T to power 2. Height of P particle, I got one expression. Let's same for a Q particle. So what is a Q particle? S is equal to UT plus half GT square. So S is the height of a Q particle is equal to U is what? 7. So I got 7T plus half times 2. I assume, let's say still it is going upwards. So height of Q is coming 7T and negative 5T to power 2. Now, according to situation, what the link is given 3 times 2 HP equal 8 times 2 HQ. 3 and 8. 3 and 8. 3 HP, 8 HQ. Let me recheck. 3 HP, 8 HQ. Correct. So now I'm going to use this connection and I can solve it. So let's see. This HP comes from here and this HQ used from here. 3 times 2, 12T minus 5, T to power 2, 8, 7T minus 5T to power 2. So 3, 4, 36T, 15T to power 2, this becoming what? 56T, and 8 5 is 40 T to power 2. Okay. Now I solve it. There's 40 T to power 2. Come this side with a minus 15 T to power 2 and plus 36 T and minus 56 T equal to 0. So it becomes 25 T to power 2. And from here I get negative 20 T. So T and I think 5 and T is common. I got a 5T and minus 4. So either 5T equal to 0, which is not possible. So T cannot be equal to 0. It is very, very clear approach. T is not equal to 0. So 5T minus 4 equal to 0, second option. And T becomes 4 over 5. And T becomes what? 0.8 seconds. So it means this is the time it satisfies. Okay. It satisfies when it satisfies this condition. But what the question he is asking, he's saying, no, find the velocity of the both particles. And this is a very interesting part about to come now. You will understand, inshallah. So he said that find velocities of both. And all of you know, I will use this formula now, the upper one, because we need a velocity. So let's start. For the both particle, I'm finding for P, for Q. V is equal to U plus AT or GT. V is equal to U plus GT. Okay, now V equal to U. U is what? 12, and gravity is negative 10, and time is 0.8. You will plug in always minus 10. You know what is the logic behind? You'll come to know, inshallah. You'll come to know now. And let me check time is speed is 7 and 12. 7 and 12. Starting speed 7 and starting 12. And here answer is coming what? Let me calculate. So 12 minus 8. I got a 4 meter per second. And positive. Whereas the other answer is coming what? 7 minus 8. It becoming negative 1. And you can see from here, this velocity is what? You know, it's coming negative, it's coming positive. And let me tell you one thing. The observer's eye is below here. Observer's eye is below here. This is observer's eye. If observer's eye is here, so what happens? This particle is going away from you, velocity positive, and this coming back toward you, velocity negative. Look at it. Is this going away, velocity positive? If one coming back to you, velocity negative. And I can sense from here even that exactly one velocity is positive and one is negative. And what was he was asking us? The question he was asking us, what find velocities P and Q at this moment. So it is mean it is our answer is correct. How I know got correct? Because at 0.7 seconds, the first particle stops and turn back. And it means that is why you can sense that this 0.8 second is after 0.7 and is turning back. That is why I got what? I got here negative 1 velocity. Because he asked me velocities, so I will not eliminate the minus sign. Or you can say even velocities for this is a 4 and this velocity is 1. You can eliminate the minus sign even, no issue at all. And but minus sign representing what? This minus sign representing that particle is coming back. This is particle is going up and this is particle coming down. This negative sign expressed. So I hope so. The point is very, very